Today, we're going to be solving container with most water. This problem is asking us to find the maximum amount of water we can store in a container. We are given an array of heights in an integer format, and each integer represents a height for a wall in the container. Important thing to pay attention to, the container cannot have two different heights because the water will spill from the uneven height. So we can guarantee the height should be one of the shorter heights to keep the water inside the container. So in this picture, we can see that the height chosen is 7. We can't choose 8 because then 8 and 7 will have a spillage in the water. And if we choose 8 and 8, the highest height, then we will get a shorter area because the width is going to be 5. So that's why choosing 7 as the height and 7 as the width is going to give us the max area. So now that we kind of understand the problem, let's get into solving. So to find the area of a rectangle, we know that the things we need are height and width, right? So those are the parameters we'll be needing, but how do we figure out how we find our maximum area, maximizing our height and our width too, right? So we know that the heights are given to us in our input array. These are basically all the heights. So we're gonna have to pick one height from there, obviously. So we can just kind of take height I and height of j and find the absolute value or the minimum value between it. For the width, though, the way the width is going to work is basically going to be the distance between the two heights that we choose. So notice over here that we are going to choose 7 as our height. So our width is going to be the distance between the 8 here and the 7 here, which ends up being 1, 2, 3, 4, 5, 6, 7. So that would be our width. So that gives our area of 49. Now you might be thinking, why don't we choose the 2 8s as our maximum area, right? And that's a good question, but so our height would be 8, but then our width gets reduced to 5, and that gives us 40, which is less than 49, where we take 7 as our height and we have a longer width. So the brute force solution to this is pretty simple. We are going to have a double for loop through all of the heights, compare the two heights, take the lesser one because that's where we're going to draw our container, remember? And then we find the width between those two, calculate the area, and then just return it. Let's code that out. This is going to be pretty simple. We have variables to keep track of our area, our height, and our width. And then I'm just going to make a simple double for loop. We want to start our I and j loops at different points of the array. And then I'm going to initialize my height to be the minimum between our for loops so we don't have an overspill like we talked about. And then our width is just going to be the distance between both those points. And I want the maximum area, so I'm just going to do area equals math.max between the new area and the current area we have. And then all I need to do is return area. And that should work. That is our brute force solution. But notice how this is taking forever to load, and it'll give you a time limit exceeded error. Let's go on to the optimized solution of this. But let's say you're in an interview and you need like a quick, easy solution just to say that, you know, you can understand the concept, you understand what's going on. This is what you need to do. A hint though, if you're usually using double for loops and, you know, you're dealing with like a max problem, probably gonna have to use 2 pointers. So this problem is going to be a 2-pointer problem. The optimized approach is pretty similar fundamentally in terms of finding the height, the width, and the area as the brute force approach. But instead of having 2 for loops, we're gonna have 2 pointers and no for loops. And we're gonna have one at the start and one at the end. And essentially the biggest difference here is going to be how I move my pointers, right? And the objective of how I'm gonna move my pointers is basically whichever pointer has the greater value, I'm gonna keep that and I'm gonna move the other one. So for example, in this case, my pointer 2 has a greater value of 7, so I'm going to move pointer 1. And that is because I don't want to lose the opportunity of having the height 7, because now I get a height of 7. But let's say I kept my pointer at 1 and I moved the right pointer, I decremented the right pointer, now my height is already below. So I always want to be optimistic about my approach in a sense where I want to try finding the maximum value possible. I have area, height, and width, and now I'm gonna add int. I'm just gonna call it left for my left pointer, and that's gonna start at 0. And then int right, which is going to start at the end of the array. And remember, we want a -1 for out of bounds exception errors and stuff. And I don't need this double for loop anymore, essentially, because I'm going to be doing that with my pointers. And instead, what I'm going to be checking is while my right pointer is greater than or equal to my left pointer, I want to keep calculating my area, right? That means that my right pointer is always ahead of my left pointer. I'm just going to paste this code in here. Oops. Because it's going to be the exact same. But there's going to be a few changes here, right? So instead of height of I and height of j, because I don't have 2 for loops anymore, it's going to be height of where my left pointer is and height of where my right pointer is. And then for my width, it's not going to be I minus j, it's going to be right minus left. And then for my area, same thing. We just want to see what the max area we can find is. And now for actually moving the pointers, like I said before, we want to keep the maximum value of where our pointer is at. So if height of pointer, of left is greater than height of right, then I want to write minus, else left plus, and that should work. And there we have it. That is the optimized solution.